Well, welcome to our new module. We are working in systems of equations. We're in module 6 now for algebra. And in module 6, we're going to be looking at what's called systems of equations, where essentially we are looking at lines and parabolas and circles and graphs of all different kinds, mainly lines, but all different kinds, and looking for what's called solutions, in other words, where they intersect. So some different things that I want you to focus on for this unit or this module's work are these big ideas, as well as looking at these sort of structures. So some of the big ideas that we're going to be looking at is we are going to be looking at one or two or more equations and looking at how they sort of relate to each other. So that's one of the big ideas. So question that we're going to be answering is, what are systems of equations? Systems of equations are quite literally two or more equations and looking at their intersection or lack thereof, potentially. So systems of equations, two or more equations, two or more, how do I want to say this? Two or more equations, and this is not beautiful, sorry. And looking at how they relate to one another. So if you had parallel lines, you would say these lines are parallel. They are never going to intersect. If you have two lines that are meeting at perpendicular angles, you'd say they meet at 90-degree angles. Or in all of the other capacities, which is so many more situations, we're going to be looking at two lines that intersect at random angles. And I'm not going to ask you like how they intersect, but I'm going to ask you where they intersect. We're going to be looking at these in three different ways. We're going to be looking at them in terms of graphs. We're looking at them in terms of what's called substitution. And we will look at them in terms of elimination. We'll have three different major methods to solve these. And the first one that we're going to focus on with this particular lesson is graphing. Okay? Some structures that I want you to be aware of in systems of equations. We're going to be looking at a lot of points, but then we're also going to be looking at writing systems in a very specific way. That specific way requires us to look at those big, huge brackets. So a big, huge bracket. And we're quite literally going to write one equation on top of another within these big, huge brackets. So in algebra, we typically focus on just two equations most often. But when you get to algebra 2, you're going to potentially have three equations, maybe even four equations. You're going to have to look at how all of those relate to one another. Now, what's kind of cool is if you have one equation with two variables, you can never find just one solution, because technically you're going to find all of the solutions along the point or along the line, unless you're given, like, say, find what this equation equals when x equals 1. The thing is, when you have two equations, you can definitely find what's called a solution. So in other words, you can look at two equations and find a point where these two equations intersect. And that, in all reality, is what we're focusing on for this entire unit. So we're going to be looking at systems written with these sort of brackets. So let's play around with it really quick before we move on to the next video. So we're going to look at that exact system that I just wrote down. We're going to look at this. Oh, of course, my bracket now is awful. We're going to look at this system. 2x plus 5y is equal to 8. And 3x minus 2y is equal to 5. And I want you to tell me, or we are going to work out together, if this point fits, or is this point a solution to this system? So in other words, is this point the intersection point between these two lines, is what we're asking. So what we are going to do is we're going to plug these numbers, this x value and this y value, into both of these equations and see if they're true statements. So I'm going to say 2 times negative 1 plus 5 times 2 is equal to 8. And I'm also going to have 3 times -1 minus 2 times 2 is equal to 5. And I'm going to solve both of these number sentences now and figure out if they're true statements. If they are true statements, we can say that this solution or this point is a true solution or an intersection point to this system. So 2 times -1 is -2 plus 5 times 2 is 10 is equal to 8. -2 plus 10 is equal to 8, which is a true statement. 8 equals 8. This whole thing is good for this particular point. Now let's see if the other point is. So if we solve this one, 3 times -1 is -3. 2 times 2 is 4. So -3 minus 4 is equal to 5. -3 minus 4 is -7. -7 and 5 definitely are not equal. So therefore, this is not a solution, or that point is not a solution to this equation. Therefore, this point is not a solution to this system. Now, it is a solution to one equation within the system, but because it's not a solution to both of the equations, it's not the intersection point. You're going to look at some other points just like this in your must-do practice problems, and I'll expect you to be able to do the same thing and say, like, this point, is this a point that is a solution to the system? And you should be able to go through the same thing. All right, we have 3 more videos for this, 2 more videos for this lesson. There's going to be one on graphing that's going to be fairly basic, and there's going to be one a little bit more complicated. After you watch those 2 videos, you will be set and ready to go for the rest of the unit, or for the rest of this particular lesson. Cool? Cool. All right. I will see you shortly. Bye.